Going to join a meeting now.
I was just thinking, isn't it absolutely typical that it pops up on screen right on cue?
Would have been worse.
I might actually try to just in case they start firing loads of stuff in the chat and things. Where's Teams? I might actually get rid of Teams. Where's it gone to?
Ready to go.
Teams. I'm ready to go. Yeah.
Okay, so let's make a start. This is the last session of the day. I've just got one administrative announcement before we get started, which is that there is a feedback form. You'll be amazed to hear. So if you'll be getting an email anyway, but also the QR code is kind of popping up on the screens outside. So please just take, it's really literally a 2 to 3 minute thing. Please give us your feedback. It's really useful, and we need to bring lessons learned into the next time we do this. Our impression is it's been a good conference, but we need your views. So thank you for doing that, and welcome to Alex. Alex is a geospatial specialist at Geological Survey of Northern Ireland. And I think we've established you are the only Northern Ireland representative at this conference. So yay, Northern Ireland.
Yay.
So betteropendata.com, a personal project that aims to improve access to LiDAR in Northern Ireland. So
yep.
Alex.
Perfect, Grant. So everyone's been doing that. What about me? So I've been with the British Geological Survey for 22 years. British Geological Survey staff the Geological Survey of Northern Ireland, which is an office within Northern Ireland government, delivering geoscience information and advice to Northern Ireland government. A lot of what I'm talking about today started off as kind of like just a project I was working on when I got a bit of free time while my wife was watching the 9 o'clock news, and has subsequently fed into some of the things that we're doing in the office, some of the things I'm doing with data formats and data delivery. So this starts with a little caveat. People who made the original data aren't in the room, but I'm just going to say it anyway. The format I'm going to talk about, which is going to be Cloud Optimised Geotiff, it wasn't around when these data were acquired, and the data I know are unsupported. It's not a criticism of the original data. I don't expect people to go back and fix data they acquired 5, 10, 15 years ago. But I really, really like the data. I use it my day to day, and that's why I've undertaken the project to do this work. So I started this off usually with why standards, but there's been a really good standards talk already at this conference, and I suspect most of the people in the room are pretty up on their standards. So basically OGC standards, internationally recognized specifications that let different systems exchange information. And if you go to the OGC website, you'll get standards for almost every specification and service and transfer format. But why should we use them? Well, they help us with interoperability, with data consistency and quality, efficiency and cost savings, scalability and future-proofing, compliance and collaboration, and they can also help us avoid vendor lock-in, which is probably one of my favorite reasons. And in today's presentation, it's not any particular software or storage or delivery platform. So as I've said already, I'm going to talk about Cloud Optimised Geotiff. It's a relatively new OGC standard, published in sort of adopted in October 2023. And it's a backward compatible type of geotiff that's designed for performance, so it allows you to retrieve parts of the data without reading the entire file. As I said, compatibility works with most GIS software. If you can open a TIFF, you can probably open a COG. It works with cloud platforms, web libraries, etc. Can help us with duplication of data. You can use the same file for your primary internal storage of your data, and the very same file for delivery of that data to the end customer without having to create caches or create web views or anything like that there. Designed for scalability. They work with really, really large data sets. And yeah, how do they work? They work really, really well. So there's two things. Not going to get too much into the details about the file structure and about HTTP technologies. So COGs are structured. They're a specific type of geotiff with an index at the top of it that tells you where to retrieve certain parts of the data that's held within the data format. And we use HTTP range requests, which is a way for us to request specific parts. So just give me that little bit of information here without reading the entire file. So you probably all use HTTP range requests because there's so many streaming things. Like think every time you go on YouTube and you click halfway into a video and it just plays. And most people are probably using COGS because Planet kind of predominantly put all of their data out in Cloud Optimized Geotiff format. All right, so on to compression, the bit that you're interested in. And basically there are lossy and lossless compression options available. And in the examples that I've got here, in the case of this LiDAR data set for Northern Ireland, we can get the data down to about a third of the original file size with absolutely no loss of resolution using the Cloud Optimized Geotiff. So the speaker notes has got some information on those compression methods. This is an example. On the top, we've got a digital surface model, and on the bottom, we've got a digital terrain model. So the original ASCII data in this example was 1.2 gigabytes. A normal geotiff sort of goes up to about 1400 megabytes with all its overviews, etc. But then when you start applying compression algorithms, so you can use LZW, you can use Deflate, you could use the Z standard compression that Meta put together. You can see that the file sizes are reducing there. And then once you start putting in the predictor, where you store the difference between values rather than the actual values, you can get that there down to, in the case of the top, sort of 400 megabytes when you started with sort of 1.2 gig. And in the bottom, because the digital terrain model's got less difference between the pixels, that goes down to sort of 350 megabytes instead of 1.2 gigabytes. So immediately, if you're sitting, this is a sort of 1 gigabyte file, but if in the work scenario where we hold digital surface models from about 2016 through to present in the Ordnance Survey fly, and it's 292 tiles a year, of sort of 2 gigabytes a tile for sort of 10 years. If you're starting with, and the scenario is that you start and the files are about 2 gigabytes, and once compressed, they come down to 800 megabytes. You're really, really reducing your storage that you need to store that on disk, and therefore you're saving some costs with that there. There's a slide here. So in the original data is about 150 gig. With Z standard, you get down to sort of 43 gig of data that we're going to take a look at in the presentation. So the compression is really, really good. How do you make a cog? So there was a presentation yesterday. Everyone was talking about GDAL. It's really, really simple. I don't know why the next line isn't formatted correctly for the color. It's just kind of a bit funny. But basically, you can read a file, read it in, output your file, and then here, this is the magic part. So we're going to output a Cloud Optimized Geotiff. We're going to use Z standard. It's going to be a big TIFF because we're going to deal with a file that's going to be bigger than 2 gigabytes in its output. We're going to use Predictor 2, and in this case, it's going to be an Irish National Grid. And that's all you need. So if you've got a Geotiff that you want to try putting into a cog to see what you can get, that's sufficient code to do it. If you've got, let me go back to that. And if you've got a folder of TIFFs that you want to do it with, that there would be sufficient code to do it. So go away, take it, try it on a file. You'll see what sort of compression you can get out. Which gets me to better open data. So this is an experiment. I just want to have fiddle with a few things, and I needed a domain name and I couldn't come up with anything better. So what did I do? So I sourced some LiDAR data from Open Data NI. This is data acquired by Department for Communities, Rivers Agency. I wrote a bit of Python that uses GDAL to download a zip file from Open Data NI without uncompressing it, look inside it, look for the DTM folders and DSM folders, create a virtual raster tile in GDAL, and then write that virtual raster tile out to the Cloud Optimized Geotiff, and then tidy up and delete the zip file that it had downloaded. So basically, it hits the web, creates your Cloud Optimized Geotiff, and just iterates through a list of about 190 of them. Did some analysis of them. There's links to the analysis and the results, and it turned out that some of the data was in millimeters for height, some of it was in centimeters, some of it was in meters. So I fixed that, and then I decided to have a bit of fun because I want to try and play with some of the AI tools to build up a very, very quick web application. I never learned JavaScript particularly. It's one of the few things I didn't actually really learn, and I created a stack. So as I said, I used open layers. I used the geotiff.js library. So if anyone wants to work with geotiffs in the web browser, this is a really, really neat library to work with. And as of about 3 months ago, it's now compatible with Z standard compressed TIFFs. And then I put together, if anyone was in the talk before lunch about hillshades, a custom hillshade function to display the raw pixel data as an interactive hillshade. And let's hope the internet's working. All right. Hopefully this works. So I'm going to turn a couple. Let me get my mouse cursor first of all on the screen. Where's my mouse gone to? There we go. Okay, so this is what I put together. There's a load of data sets here. We can scroll down to the bottom. We can see them. We've got information about where they came from. It's got information whether they're 20 centimeter pixels, whether they're 1 meter pixels. They're in a list here. So what I can do is I can go in and I can grab Belfast. If anyone hasn't been, you can go over and visit. It's a lovely city. That's Belfast. So this is just loading the Cloud Optimised Geotiff. East Belfast, where I live, is there. We can go through and we can grab in Bangor, where I grew up. The extension to the Bangor that was carried out. We could go in. I'm going to grab a couple more of these here. Grab Newton Ards, and then I'm going to grab Newton Abbey. So that's loaded in lots and lots of separate, in this case, Cloud Optimised Geotiffs, because some of them are 1 meter resolution, some are 50 centimeters, some are 20 centimeters. What I'll do here, I'll grab one called Cave Hill, which is the big mountain that overlooks Belfast, and it's a 20 centimeter one. So what I can do here is turn them on and off. It's got the usual things that you can do with this here. As I said, there's a custom hill shade, so we can change the vertical exaggeration on this here. We can change the sun angles on these here. But what I can also do is zoom in, and it will load in the Cloud Optimised Geotiff straight into the web browser. So the Cloud Optimised Geotiff is literally black and white pixels. All of this shading's happening in the web browser using JavaScript. Having read the data in. So we've got this in and we're able to zoom in and we're able to look at this. And if we turn this on, we can probably take off all the trees and start to look at all the paths, because that's really, really nice with the LiDAR data. So as well as that there, I thought it would be fun because I really, really like the elevation filter in QGIS to try to implement an elevation filter. And I think it took about 15 minutes from deciding to do this to getting something functional, thanks to Claude Sonnet. So basically, we can start to strip back the pixel data in the web browser, which is lovely. We can do the same thing coming up from the bottom, which is less lovely because you'll see that Belfast is really quite low lying, and unfortunately, I live about there. In fact, if we go in here, that's my house there. The other thing you'll see, because this is hill shaded in the browser, up in the top right, we're reading the actual pixel values. So here, I'm about 12 meters above sea level. But it's really nice. So the data set does not look like what you're seeing in the web browser here. This was just me having a bit of a fun play to see what I could do to put together sort of a quick web map. And it works really, really nicely. So all these files are, if I very quickly, is it going to work? Is this going to work? No, it's not going to work. I was going to try and nip forward to show you what the actual data looks like. But essentially, look at the geomorphology there. It's absolutely wonderful. Are there any geologists in the room? They get really, really, really excited about this. We will map off this here. But essentially, all of this data is just sitting as geotiffs, and it's being pulled straight into the web map, and it's being symbolized and stylized like this here. You can change the elevation. You can take that down. You can emphasize it. We can change the sun angles. Makes it really, really nice if you want to do some quaternary or glacial mapping. So that there was kind of the kind of put together the web app thing. We've got bits here where we can filter it. So we look after all the abandoned mines for the department. So there's lots of mining in Northern Ireland. So I've just added in the Laz Hill data set to the map here. And we are able to copy the URLs to the clipboard. And I'll get to why we're going to do that in a second. But essentially, this was just a really, really quick web view to kind of chuck a whole load of LiDAR data sets of different resolutions together and see what it looked like. And it's really, really functional. It's really, really fast, which is what I'm most impressed about. And I normally say at the end of this, everything I'm doing is running from a Raspberry Pi as a web server on my home internet. But I'll say that now. So it's running on a really, really lightweight computer. The data should obviously be in a bucket somewhere, but this was me having a bit of a play. All right, so I also put together a stack, a spatial timber asset catalog. Electrical Consulting, I think some of them are here, did a really good job implementing stacks in QGIS. So we're able to copy a stack catalog address and put it in. And there's a little bit here about data formats and about how to make Cloud Optimised Geotiffs, etc. Right. If anyone once there's videos for all of these here. I should have escaped out of this here. Let me go to function F11. I want to jump into QGIS. All right, so I've copied a URL, and I think yesterday we were chatting again about adding a layer, so we can add a raster layer. We can do that from an HTTP protocol. That could be HTTP there. We can paste this in. We can paste the URL in, which I think I copied. All right, let me copy a URL. Let's go back 2 seconds. I need to go back to where's the website? Hang on. I'll just grab a URL here. For example, we'll copy ArcStraw. We paste it in, and you can add that there to QGIS. So ArcStraw is loaded in, and we can zoom to layers, and that's what the Cloud Optimised Geotiff actually looks like. It doesn't look like anything you saw in the web browser. It's just black and white pixels. So you can copy and paste an individual URL in. You can go into the QGIS browser. You can go to a stack catalog, which is under the stack. Create a new stack connection, paste the URL in, and you can drag and drop, for example, Londonderry into the map, and zoom up to Londonderry, and you'll get the same thing. You'll get an image, but it allows us to do better things than that. QGIS is really, really powerful when it comes to working with rasters. So there's the one for Slemish. I've picked this because it's got some nice elevation in it. Some of the things I like doing QGIS, I like being able to look at on-the-fly contours in the symbology. So this is the contours in QGIS for the dataset, and as you see, as I zoom in on this, the resolution of those contours is improving as the range requests come in for the different bits of the Cloud Optimised Geotiff. We're also able to create a hillshade, which looks pretty nice. It's great. I've been on 5 minutes. Looks pretty nice. And then we can also blend those. So we can have our hillshade with, if anyone was in the creating hillshade stuff before lunch, there's lots of ways you can do this, but you can obviously then blend your color ramp with your elevation model and kind of make something that looks really nice. And this is only pulling in the bits of the data that it needs in the view that you're looking at. So you could have like terabytes worth of data set somewhere, but it'll only ever load the bit that you need to display the mapping in your desktop GIS. So that's really nice, and it works really well. I'm going to go back to my presentation, which unfortunately I shouldn't have closed. So bear with me. As you see, there's loads of slides, there's loads of notes. People can get hold of that there. Most of the code for all this is on GitHub. This is the bit where I do where's the data? So this is actually genuinely all running on a Raspberry Pi in my house. And it works pretty nice. And I know that there's colleagues across Northern Ireland government are pulling it in from my house because it works really, really nice for them. And I've stuck the website on GitHub pages, but essentially the biggest issue is what do you do when you've got 40 gig of LiDAR data that you don't want to get a really big bill from a cloud provider for because somebody's decided to hammer the bucket and rack up a load of charges. So ultimately, it should be in S3, it should be in R2, it should be on Open Data NI, which is where ultimately I hope it will go back to. So essentially, all the work I've done to kind of standardize the elevations, to fix some of the things with the values that are in it, and to create a file that means that every user that wants to use the LiDAR data just needs to download the LiDAR data from the Cloud Optimised Geotiff directly into their software, as opposed to downloading it, processing it, creating virtual raster tiles, doing all the work I did. So hopefully we'll get it back onto Open Data NI at some point. So to pull it back to where I've been using the stuff with Cloud Optimised Geotiffs in my day job, we've been doing lots of drilling for geothermal energy schemes with the department. We drilled a big borehole at Stormont. The home of Northern Ireland government occasionally makes it onto the UK news. And we took photographs of all of the core. So I've done the very same thing here. We've created essentially a massive Cloud Optimised Geotiff of the entire sequence of the rock core. It's RGB imagery, but we've stacked it all together, and you can put it in your web browser, pan around, look at it at really, really high resolution. And it's a really, really neat way of having a file that you can just give to a researcher. They look at this, they decide this is the interval of core they want to come in. They want to look at this bit of core, we can pull it out, let them look at it, they can do their research on it. So I was obviously looking at this from a LiDAR and doing something kind of neat with that. The implications are we can deliver lots and lots of our data as Cloud Optimised Geotiffs. It can save us loads of space on internal storage, particularly where we're consuming things from the Ordnance Survey, and we can reprocess them to kind of use a third of the storage space. Why wouldn't you do that? Especially whenever the data is unlikely to ever be updated because it was acquired years ago. And that brings me, with 2 minutes to spare, to the end of my presentation. So that's a really, really rapid. Sorry if I spoke really quick. The link is there. The PDF slides that are on the registration page didn't render particularly well, but there's a GitHub link on the first page so you can get back, and then there's all the codes on GitHub. And yeah, any questions?
Yeah, thanks very much, Alex. And that looked really nicely with the session before from Tom. So, put those two together and pretty much do anything, I think. So, yeah, any questions? We've got one.
Yeah, so.
And if you could repeat the question, Alex, just so.
Okay, so, look back up, I'm part of we're basically working with the same sort of thing with the Scottish government. So, displaying their LiDAR data. And one of these things is something I want to be doing in this sort of creative work. Have you done any work with the point cloud, so the COPC stuff? That's the bit I'm not entirely clear how well that works yet. Anyone who's tried it.
Okay, so have I done anything with COPC data with this? It's on my, if I get some time in the evenings, I'd like to have a play with. Because we have COPC data for, well, we have point cloud data which we could convert and put into COPC. It's on my, I'd like to take a look at it, but I believe it works reasonably similarly in terms of once it's in a cloud optimized point cloud format. If you put it into a bucket, you can request the bits of it that you're looking for.
So for those who don't know,
COPC is cloud optimized point cloud. So it's a point cloud.
One thing that might help is we, for our storage of data, what we've done is we've worked with the AWS Open Data Registry. So our data gets pushed onto there, and so AWS cover the egress.
Okay.
So it's a public open data set that way. We're not, Scottish government aren't being charged for the egress costs of it.
That's really interesting because the ingress and egress costs are quite often the hidden costs in using cloud storage.
Have you done anything about trying to merge data sets across the whole of Northern Ireland so you can get sort of either by creating a massive cog or by sort of doing some of the mosaicing stuff you can do maybe some of the back end things like e-tiler and things, so you can get a sort of unified experience of Zoom anywhere in Northern Ireland and get a map? Are you going to be
Okay, so the query is, have I tried to merge this together to make a sort of a seamless map for the whole of Northern Ireland in one go? The answer to that is no, because a couple of options. We could resample everything to 20 centimeters. That would make a really, really massive cog, but then we'd have sort of 1 meter data going in and being resampled and kind of overinflates the amount that you require for that. There's also quite a bit of overlap. So some of this data has come from Rivers Agency, some of it's come from community. So some sites you might actually have sort of 2 sets of data, maybe 3 sets of data with overlap. So it was kind of to allow different data sets to be viewed individually. Be interested in taking a look and see whether there was some kind of way of almost like the virtual raster tile that you get, being able to do a virtual, well, I suspect in QGIS you could probably do a virtual raster tile of each of the cloud optimized geotiffs. I suspect that would probably work. So it would just reference each of them and create sort of a virtual raster. So instead of, well, it was one of the stages in doing the processing. I would create the virtual raster and then mosaic it. You could probably do the same thing, but I haven't tried it, so I can't say if it's going to work or not. Yeah, so we are within Northern Ireland government. I know the people from Open Data NI really well, actually. Open Data NI was put together quite some time ago. It was one of Sue Gray's initiatives whenever she was leading the Northern Ireland Civil Service. It is not resourced sufficiently at the minute to take a lot of extra data, and it's kind of running on a shoestring budget at the moment. So the idea is that whenever they get a bit more resourcing into it, I would like to sort of hand them the data back. And they have cloud storage. They store stuff. I think it's in Azure is where they're normally pulling theirs from. Certainly when I script, it was very fast for the downloads, which would be great. But essentially this was kind of the proof of concept to go like, do cogs work? Do they work in the web browser? Do they work in the desktop? Can I use these for doing my block core on the screen and things like that there? And it was a really nice proof of concept. It works really, really well.
I've got a quick question, Alex. You talked about the storage benefits of cogs as against normal geotiffs. Do you have any idea about the metrics on the sort of delivery, upload, download speeds and so on. The performance essentially.
So everything I was doing there was running from a Raspberry Pi. It's on my home internet. So you're requesting really very small amounts, very, very, very small amounts of data. I've not logged sort of the amount of bandwidth that's being transferred when you make a single request on it. But the example that I was super intrigued from the before lunchtime presentation from Address Cloud was that they have a Lambda function running in AWS where they request just a building footprint. So they've got a Lambda function, so they're only ever going, just give me these couple of pixels, or just give me the highest value within these couple of pixels to kind of retrieve it. So that's kind of interesting. I guess my use case for this was, I want to map from this. I want to map the landforms. I want to map the drumlins. I want to map the kind of the geological features that I can see. So I want to look at the full data set as opposed to little bits of it. But it's a really interesting use case.
Great. Dan, last question.
Yes. It's all the stuff you're doing, like kind of the shade and summon. Is that you just using
No, it's not open layers. So to read the Cloud Optimised Geotiffs, I'm using geotiff.js, which is a JavaScript library. And then, as I say, the idea of doing some of the hill shading, so a lot of that was put together with Claude, with the Anthropics. I think it was like Claude 3.5, so it's really old now. And that was basically like, I don't know the math to write all of that there, but I was able to give it sufficient prompts to implement that. It took like 15 minutes. And I was like, I can make these really cool hill shades, without needing it. So I can't write JavaScript, essentially. So I was able to do the hill shading aspect of it and implement something really, really quickly because there was tooling. And part of this was having a play with things to see what I could do with these. My background, I write Python. I just, JavaScript was one of those. It was kind of, never learned it. Probably still should. But which version of JavaScript do you learn?
Well, the best stuff comes from people having a play.
Yeah.
Good. Thank you very much, Alex.